Welcome to this presentation for the Oscar 3 design. What we'll cover is what an Oscar 3 system is, its treatment capacity, basics of the design, and we'll go through a small photo gallery of what the systems look like when they're completed. The Oscar 3 is very similar to the other Oscar products. It's an on-site sand coil area recharge, kind of describing what it is and what it does. It is a treatment technology as well as a final disposal component, all in one. And looking at the treatment capabilities from a CBOD and TSS, what we see here is a graph of the averages of the 6 months of the NSF test. We have in the two tall columns the influent into the system, roughly about 230, 240 BOD TSS. The smaller bars represent the effluent of about 2 and 3 BOD TSS, and the red line represents the 15 milligrams per liter limit for treatment standard B in the state of Washington. Here's the same type of graph or chart that we have for the fecal coliform. The tall bars represent the influent fecal coliform levels. They range from about 4 million to almost 100 million fecals per 100 mils. The small bars represent the effluent from the Oscar, and again the red line represents the upper limit for treatment level B. As you can see, we've easily met those criteria. Now the two main components for the Oscar 3, we have two types of coils. We have the OS50, which in the Oscar 3 will work for a 25 gallon per day design flow. The OS100s will operate the 50 gallon a day design flow. The other main component for the Oscar is the C33 sand, and in the Oscar 3 we need a minimum of 12 inches of sand underneath the coil for the treatment media. The normal OS50 configuration will look very similar to this. It's 25 lineal feet of tubing with 6-inch emitter spacings for a total of 50 emitters in a roughly 25-foot square area. And here's an illustration of an OS100. It has twice the amount of tubing, twice the number of emitters, and is encased in roughly twice the square footed area. To kind of compare and contrast a little bit between the OS50 is and we're going to have to slice in a slide here because this isn't going to work. Mess this one up. Now, the two different coils, to compare them, this is for a 240 gallon a day design flow. The upper illustration is using the OS50 coils. You can see that minimum length of the basal area is 57 feet long. In the bottom illustration, using the OS100s, we're only at 38 feet long. So there's quite a reduction in the overall length. Now the square footage will stay the same, so the 5-foot coils are going to be long and narrow, where the 7-foot coils are going to be somewhat shorter length but a wider basal area. The other thing that is to note here is the OS50s in the top illustration. We can have as little as 12 inches of soil to install this system. We're using the OS100s in the bottom illustration. We'll need to have a minimum of 18 inches of soil underneath the sand layer. Media depth, if you're familiar with any of the other Oscar products, this will be one of the differences in that we need to have, again, a minimum of 12 inches of sand under the coils. In the remaining parts of the basal area, outside the coil area, we only need to have 6 inches of sand to the edge of the basal area. Now the basic layout of the system, again, we're going to need to have a minimum of a 1,500 gallon septic tank. This could be a double compartment or a single compartment. It could have an outlet filter baffle or not. Either way, there is no requirement for number of compartments or an outlet filter baffle. The discharge tank will be 1,000 gallons, and depending upon the design flow, the Oscar number of coils and size will vary according to design flow as well as soil type. But these tankage would be for a minimum of a 500 gallon a day system. Now, some of the things that we're going to go through on the actual design is we're going to look at the standard packages. What we're attempting to do is with our standard packages, because we're designing for the specific number of coils for a specific design flow, the loading rate to the sand stays the same. So the packages are going to be consistent. We won't have to vary them according to soil type. So that allows us to do some standardization, which will help make the design process much simpler and easier. Also, the review of the regulators will be easier. And then when we come to supply the packages or the materials to the contractors, it will be more consistent. We'll cover real briefly some setbacks, go over the basal area calculations, hydraulic layout, how many coils, how they're going to be arranged, and so forth. And then we'll have to figure out the total dynamic head for the Oscar supply line. And then again, we'll just briefly mention some of the tankage requirements. Now, the standard package for an Oscar 2 kit will actually be the Oscar 2 and the Oscar 3 kit are identical. They have the same basic components. You're going to have a control panel. You'll have a headworks that will operate the 3 gauges. You'll have 5 solenoid valves and a 3/4 inch disc filter. We use the standard pump that we have in our packages as a standard AY McDonald 30 gallon a minute pump. You can see the model number there. Inside the headworks is a 3/4 inch flow meter. And then there's a few other miscellaneous parts, a couple floats, some blank tubing, float bracket, and those sorts of things. Now, in the setbacks, again, we were approved just out of the using the bound guidelines, so you're going to see very similar setback requirements for those. Now, our standard coil arrangements, again, we're using standard kits, standard coil arrangements, so that we can be consistent throughout. Using a 250 gallon design flow arrangement, it's not going to matter how many, whether we're in soil type 1 or soil type 6. If we're at a 240 gallon a day design flow, we're going to use the same package or the same drawing for those coils. What will change as we move through different soil types will be the basal area that we're dealing with, or the size of it and how much sand will be put down. We'll go through a couple sample designs so that you can see what we're talking about. Let's assume a 240 gallon a day design flow, somewhere between 12 and 18 inches of soil. We'll go through a flat site calculation, and we'll also go to the maximum of a 20% slope calculation so you can see the differences between the two. First thing we need to do is to determine what the minimum basal area or infiltrative area that we need according to state or local code. In this case, again, we're using soil type 4 as an example, 240 gallon a day design flow. So 240 divided by 0.6 gallons per square foot gives us a minimum basal area requirement of 400 square feet. Now we just need to figure out what the dimensions of that basal area are. To do that, we need to come up with the basal length. The minimum basal length is composed of two functions. One is what we're referring to as the minimum shoulder length plus the side slopes. Now, the minimum shoulder length has to do with how many coils we have, the separation between each coils, and then the separation between the last coil and the shoulder of the sand bed itself. In our design manual, we have a couple of tables, one for the OS 50 coils and one for the OS 100s. We have it broken down by the design flow on the left column, and on the right, we give the value for the minimum shoulder length in feet. Now, you can make these longer if you need to stretch it out even more. Typically with the Oscar 3, that's not the issue, but these would be the minimum shoulder lengths that you'd be needed to design for. In this case, we're going to use 55.5 feet. We also mentioned that the minimum length has to do with the shoulder width, or the minimum shoulder length, which is 55.5. But now we have to add the side slopes. The side slopes are equivalent to the amount of media that we have under the coils. On a flat site, as we're using here, we've got 12 inches. So we're going to have two side slopes, one on either end of 12 inches. So our basal area, or excuse me, basal length, will be the side slopes, which is the media depth times 2. So kind of recap, our area of 240 gallons a day divided by 0.6 gallons ends up with 400 square feet. Our basal length equals a 55.5 shoulder length, and we have two side slopes, a foot apiece. So that's going to give us a minimum basal length of 57 feet, more like 57.5. The basal width divided of 400 square divided by 57 is going to equate to about a little over 7 foot wide basal footprint. Now that's going to be a little bit too narrow, and we should just kind of round up to the next whole number. So we're going to say that the minimum basal width is going to be 8 feet with a 57 foot, probably 57.5 foot long basal area. Now on a sloping site, we're going to go through the exact same process, except there's going to be two minor changes. Again, we're going to use the same soils and same design flow rate for our 400 gallon or 400 square foot per day. But because we're on a sloping site, we're going to move the coils to the upper edge, within about a foot of the upper edge of the basal area. But we're still going to have the shoulder length and the side slopes to give us our minimum length. But again, remember, we have to use the sand media depth to determine what the side slopes are. Well, the coils need to remain level, so we need to be able to calculate or compensate for the slope for the additional sand needed to keep the coils level. It's a very simple formula. We use the coil diameter in inches, multiply that times the percent slope, and that will give us the additional sand we need to add to the minimum of 12 inches that we need to start with. So in this case, the minimum, or not the minimum, but the amount of sand that we need to have is 24 inches to keep that coil level. So that will be our side slope calculation. Again, our minimum shoulder length is 55.5. We're going to add twice the sand depth. So we're going to have the 55 foot shoulder length plus 4 foot side slopes to give us 59.5 foot should be. The basal width again is going to be 400 square divided by 59, which will give us just under 7 foot. The problem is that the basal area is going to be a little bit too narrow, so we may need to increase that basal width to 8 or 9 feet. I'll show you what it means here in a second, but we'll need to meet the 1-to-1 slope on the toe, and on the sloping site, that's going to extend out further than our minimum width, minimum requirements are going to be. Here's what this looks like. If we scale this off, our minimum basal width ends about here, but you'll see that the toe of the Oscar will extend out to about here. So we will need to actually show a much wider width, especially with the OS50s on the Oscar 3 systems. So we are going to have to compensate for this on our designs. So the last thing we want to do when we're doing an actual design submittal for the basal area calculations is we do want to show what's required by code. 400 square is the minimum. Then we need to go show what we're actually being proposed. On the flat site, it was 57 by 8, so about 450 square feet, so we're over the minimum, the 400 minimum. On the sloping site, our example, we needed 59 for about 9 feet wide, so we're looking at about 530 square feet. So we're well over the minimum infiltrative surface needed. So these are things we'll need to show on the design to demonstrate that we're meeting the local code intent. Now, the one thing that we cannot take into account in the standard package with the standard pump and the coil layout is what's going to happen with that supply line. We don't know how long it's going to be, and we don't know what kind of elevation difference we're going to have to compensate for. Now, we are making a couple assumptions on the supply line. We are assuming that it's going to be a 1-inch Schedule 40 pipe, and we're also assuming that we're going to have a 12 gallon a minute flush flow rate. So what we've done is in the design tables of our manuals, we give you lots of different numbers. We give you the number of coils, the layout, how many coils per lateral, flow rate during the dose, flow rate during the flushing. And because I've already calculated in what the minimum inlet pressure is with flows, I know with the pump that we're using, we have at least 50 feet of additional head, or what I'm calling excess head, under the pump curve to be used for the total dynamic head loss of our supply line. So here's how it works. Imagine that we have a system that we need a performance point here. We need about 12, 13 gallons a minute at about 85 feet ahead, 84 feet ahead. On this fictitious pump curve, we will have an excess capability underneath the pump curve of about 50 feet. And so this particular amount is what we can use to apply to the total dynamic head loss of our supply line. So again, friction loss, you can calculate it by using the Hayes and Williams, or just use table and then add that to the elevation plus going up to the Oscar, and that will give you your total dynamic head. Again, we're assuming 1-inch PVC Schedule 40. The pump in the package, again, comes with at least 50 feet of excessive head capability. If it turns out when you do the total dynamic head calculations, you have greater than 50 feet of head, we're going to consider that a custom design. It needs to be identified, and we'd ask that you would call us for assistance. It may be something just as simple as increasing the supply line size from 1 inch to 1.25 inches. If you did that, that would be fine, but it just needs to be identified on the design so that the installer knows what to get. In some cases, this total dynamic head may be far in excess of 50 feet, like 100 feet as an example, where we would have to actually substitute a different pump, which would require, again, the custom package couldn't work, so someone's going to have to know when ordering that they're going to get a custom package and what that means. So we'd like to have that identified beforehand. Now, custom designs, again, they're defined by having a total dynamic head greater than 50 feet, or if you have design flows greater than 480 gallons a day. The 600-gallon design flows are fairly common. We do have standard templates for the coil layout, but on your first design or two, we'd like that you call just to make sure that we're all on the same page. Now, the tanks for the Oscar 3 are pretty simple. We need a 1,500-gallon septic tank. Again, it can be a single compartment or a double compartment. It can have an outlet filter baffle if you so choose or not. We don't require one. The pump chamber needs to be a minimum of 1,000 gallons. Now, you'll notice that our pumps are, we call naked. They're just sitting on the bottom of the tank. They do not have a shroud. They do not have a screen vault around them. And then we have 2 floats there to control their operation. Again, the septic tank, does need to be on the State Department of lists tanks. Minimum 1,500 gallons, single or double. It could be concrete, poly, or fiberglass. We're not particular on the material. It just needs to meet the minimum volume requirements. Discharge tank is going to be 1,000 gallons. If you were to design up above 500 gallons a day, you would have to increase this tank size proportionally. For instance, going from 500 to 600 gallons a day is a 20% increase. Therefore, your discharge tank would need to jump from 1,000 to 1,200 gallon tank minimum. You can go larger if that's more feasible. Now, our drawings that we have on our website are all identified with drawing numbers or codes. They're all identified as such. There'll be like an OS3 240 5S, and the OS just stands for Oscar coils. The 3-digit number is the design flow. The 5 stands for whether it's a 5-foot coil or a 25-gallon-a-day system, or it could be a 7-foot coil, which is a 50-gallon-a-day design flow. Again, these Oscar 3 application rates are going to be different than Oscar and Oscar 2, so it's important that you make sure you get the right drawings. Use the Oscar 3 design criteria for your Oscar 3 designs. Now the S on this just stands for sloping site. If there was no S, it would be for a flat site. The cover material required on the Oscars, there's some controversy that people like to create around this. It only needs to be C33. It's the only regulatory requirement to be on there. If someone's just wants to cover it with something else, they can you'll have to put the minimum sand on, but you could cover the sand with a little bit of mineral soil, very low organics, 2-3 inches or so. We do recommend covering the sand with some straw, get some grass seed planted, some other kind of ground cover if someone so chooses, maybe periwinkle or vinca minor. Some people have opted to put sod right over the top, which is just fine. Jute mat, if someone wants to kind of, especially on a sloping site, you may want to secure the slopes a little bit better. What we don't want to do is have any the pre-manufactured topsoil mixes. These high organic, high compost laden material holds moisture, and so when liquid actually starts to capillary rise up through the sand from the coils, once it hits this very rich organic layer, it tends to get very moist, and it looks like we have a problem with the system, and it's a little mushy, and we want to avoid the appearance of a failure if possible. Just some examples of what some of the systems look like. The system on the left was put in, this is like after one growing season into the late summer. After a winter, you can see it's the same system, but you have a different green striping pattern, for lack of a better term. And again, this is just sand over the top of coils. There's no additional supplemental material over the top to make the grass grow. In a system that's just been installed, I think this was in early or mid-May of the year that this system was installed. Once it goes into operation, you can start to see the wetting pattern where the coils are. If it's in shade, it's going to stay moist longer. If it's in the sun, like over to the left, it tends to dry out a little bit quicker. And then over just a few short months, the grass starts to take off. And as time goes on, that grass starts to spread. Thank you for watching and your interest in the Oscar 3 wastewater technology. If you have any questions, please feel free to email us, give us a call. Our contact information can be found on every page of our website. Shoot us an email. We'll be happy to return your call. Thanks so much for watching.